De Broglie's postulate and Heisenberg's uncertainty principle. There are weaknesses in Bohr's atomic model. One of them is Bohr only explains the hydrogen spectrum or spectrum of ions that contain only one electron, such as helium ion or lithium ion. So it only explains hydrogen atom, helium ion, and lithium ion. It cannot imply the Bohr's atomic model to other atoms. It also could not predict line spectra for other atoms because it only predicts for hydrogen, helium ion, and lithium ion. He proposed that electrons could only orbit at specific fixed distances from the nucleus. Example, electrons at n equal to 1, electron at n equal to 2, electrons at n equal to 3, and so on. However, electrons in reality do not travel in fixed orbit. The de Broglie's postulate states about dual nature of electron. Initially, Einstein proposed that light, which has wave properties, also have particle properties. De Broglie further suggested that if light can behave like matter, then perhaps matter can behave like light. That is, perhaps matter is wave-like as well as particle-like. He deduced that particles such as electron possesses dual nature, which are both wave and particle properties. De Broglie used Einstein's equation E equal mc square, this is the Einstein equation, to combine with E equal h nu, h frequency. If we combine the Einstein's equation with E equal h frequency, you'll get mc square equal to h nu. Mc square equal h c over lambda because nu is equal to c over lambda, so the wavelength is equal to h over mc. For a moving particle, lambda equal h over mu. So this is mu, u, mu, where lambda, the wavelength of particle, h, the Planck constant, m, the mass of particle, mu equal velocity of particle, mu equal momentum. So we have mass times the velocity, it is momentum. The Heisenberg's uncertainty principle. In Bohr's theory, the electron was thought of as orbiting the nucleus in a fixed path. If the electron is really orbiting the nucleus in a fixed path, we would know not only the precise position but also the precise speed of the electron. However, Heisenberg showed from quantum mechanics that it is impossible to know accurately both position and momentum simultaneously of an electron. The equation for Heisenberg's uncertainty principle, delta x multiplied by mass times delta mu, this is the speed, greater than or equal to h Planck constant over 4 pi. We can determine the orbit of a large object, which means the mass is large, because the uncertainties delta x and delta mu are small. If these two are small, we can determine the orbit of the large object. But our electron, the mass of electron is extremely small, so the uncertainties become significant. If the mass is very small, the uncertainties will become greater. If the mass is large, the uncertainties will become smaller. This means it is impossible to describe how electron moves in an atom because we have very large uncertainties about the speed and the position and momentum. In reality, the electron does not orbit the nucleus in a fixed path. Thus, this leads to the concept of orbital. The Heisenberg's uncertainty principle equation, delta x multiplied by mass times delta mu greater than equal to h over 4 pi. Delta x is the uncertainty of position, delta mu uncertainty of speed, m is the mass of particle. If you're calculating for electron, it is the mass of electron. H is a Planck constant. The more accurate we know the position of particle, means the smaller the uncertainties of the position, the less accurate we know its speed, or the larger the uncertainty of mu, the speed, and vice versa. So means if we know the more accurate the speed, less accurate we know about the position. If we know more accurate about the position, we know less accurate of the speed.